Welcome to Train Signal. You're watching the Lab 3 video for DHCP in Windows Server 2003. In this video, we're going to take a look at SuperScopes. Okay, and we're going to go over SuperScopes. First, we'll do a little bit of an overview. We'll talk about why we'd use a SuperScope and then apply it to a little scenario here just to make sure that you have a better retention of how and when you'd use this SuperScope. So we'll do a little bit of an overview. Then we're going to have to go back and recreate our lab, do a little bit of computer setup to create this situation. And we're going to go through the actual process of doing the SuperScope. So we'll create two separate scopes, do some scope options, exclusions, actually create the SuperScope, which is a really simple process after you have everything set up. And we'll do some testing just to give you a feel for exactly how this SuperScope is going to work. Okay, first thing we're going to do, or actually let's go back in here and take a look at this overview diagram, just to give you a feel for what we're going to be setting up right now. Okay, so right now, as usual, we're sitting on XP1. XP1 is going to have its usual role as a DHCP client. Server 2, this is the machine that's been a DHCP server throughout this entire series, so we're going to leave this machine as the DHCP server. Now, one thing that you might want to notice here, we see that we have two different IP addresses, 192.168.1.200, and then also 192.168.2.200. Okay, this is something that we have not done yet. We'll set this up, and what's essentially going to happen is we're going to be using multiple IP addresses on here to service both of these scopes that we set up. So that's one of the first things we need to do is talk about what the heck is a SuperScope. All right, so let's talk about the situation first. We've got a domain controller. This is going to be also running DNS and WINS. So this server is just like we've had in previous setups. Nothing different here on server 1. Server 3, we're going to pull this machine off. We're actually going to uninstall DHCP off of server 3, and we're going to make this machine a DHCP client. Okay, so normally, we talk about this. We're going to statically assign IP addresses to servers. Well, in cases, there may be a case where you want to use DHCP, and you could even set up a reservation, so server 3 is always getting the same IP address from that DHCP server. Okay, and for our purposes right now, this is just testing, and we've got this machine handy, and it's going to be easier for you as well if you're following through and you're building these on your own. Okay, so we're just going to uninstall DHCP, change the IP address settings to obtain an IP address automatically, just so this machine is going to be acting as a DHCP client. Now, here's the situation. Before, when we were dealing with this, we had 150 or so DHCP clients, and we could easily handle this within one IP address range. Okay, remember, the IP address range 192.168.1. whatever is going to give us 254 valid IP addresses between 1 and 254. Well, if we assume growth in the company, okay, maybe we're to the point now where we have 300 or 400 different computers, or we're going to be adding this number of computers very shortly, and we need to plan for growth. One thing we can do, of course, is to create multiple subnets. Okay, and creating multiple subnets, a physical subnet, would involve adding a router. You might have another Ethernet segment. You might see something like this, and we draw here a router. Okay, and we have another Ethernet segment. We start adding servers and whatnot over here. Okay, so it involves a little bit more complexity, a little bit more expense, because you're going to have to invest in, your router and your Ethernet equipment, that sort of thing. This is the best way of doing this, but we do have an alternative. Okay, and if we want to use DHCP in a situation like this, what we can do instead is create what's called a SuperScope. Okay, and a SuperScope, what it's going to do, SuperScope will allow this one DHCP server here, okay, to actually give out IP addresses from two different ranges, the 192.168.1 range and the 192.168.2 range that you see here. Okay, it's going to allow both of these ranges to be given out on the same subnet that you see here. Okay, normally, let's talk about what would normally happen. If you set up two different scopes, okay, 192.168.1 and 192.168.2 with the associated IP addresses, this machine, since it has an IP address of 192.168.1.200, would only give out IP addresses on this one particular segment here from the scope of 192.168.1. Okay, if a computer came requesting, if it's just requesting an IP address, it would never give out an IP address from that second scope that we see here. The only way it'll actually pull IP addresses from this second scope would be in a case where, just like we had a second ago here, where we've got this router situation, we've got another segment over here, okay, and the segment over here, maybe this is the 192.168.2 network. Okay, so we have a DHCP client over here. This machine then comes across this router, talks to the DHCP server. Okay, this DHCP server is actually smart enough to figure out what physical subnet this machine is broadcasting from, because the broadcast is going to have information that's attached to it by the router. Okay, so think about this. This machine broadcasts out. This broadcast, and this is something we'll talk about in the next lab, is configured to pass through this router. Okay, the IP information that's included by this router, it's included within the packet that's sent over to the DHCP server, is enough for this server to identify that this machine is coming from this physical subnet, 192.168.2.0, okay, that network ID. So what it's going to do, instead of giving it an IP address from the 1 range, which will be invalid over here, it'll give it an IP address from the 2 range, which will suit this computer just fine. It'll be able to talk to any of the resources that are over here on the second subnet, and then also it'll just stay within TCP/IP guidelines. So we'll be able to have normal routed communication back and forth between subnet 1 up here and then subnet 2 down below. Okay. Now, never though will a machine here broadcast out and accidentally get an IP address from 192.168.2. It's never going to get an IP address from that scope. And the reason that is, well, it's because this machine's broadcasting out. It's not having to pass through any router. So when the packet reaches the DHCP server, it's smart enough to realize that this machine is on the exact same segment that it is on. Okay, and when that happens, it's just simply going to say, oh, okay, I know you, buddy. I'm going to give you an IP address that will suit you just fine over here on segment 1. Okay, and that's exactly what we'd want. Think about what would happen if this DHCP server actually gave this computer an IP address that was 192.168.2 dot whatever, 2 dot, let's say 1. Okay, so an IP address from this scope. Well, according to TCP/IP guidelines and rules, the way the protocol works, this machine would be on a totally different network ID than these other servers, and no communication would take place. It wouldn't be able to talk to this machine, wouldn't be able to talk to this machine, it wouldn't be able to talk to the router. It would basically be on an island all by itself, and this machine would pretty much be useless from a networking standpoint. Okay, no internet, no email, no files, no printing. It can just simply work on its own. So that's not a good thing. So we need some way to make sure that this machine gets an IP address from the right scope. Okay, and there's nothing that you have to do. This just happens automatically. Now, on to the topic that we're discussing here in this lab. What a SuperScope does is basically takes that requirement away. Okay, remember a second ago we talked about this, that if this machine broadcasts out, we're only going to give it an IP address from this range. Okay, well, what a SuperScope will do is say, well, let's join these two ranges together, the 1 range and the 2 range, and we'll basically pretend like these are the exact same network ID, because what we're going to do, we've grown a lot, we don't have time to set this up, or we don't have the money to set this up, we need to service 250, 300, 400 different computers, and each one of these scopes will only service roughly 254 computers. So what we'll do instead is we'll join these two together so we get in the neighborhood of 500 different IP addresses that are now available. Okay? Let me repeat that. We're joining two scopes together, the first scope and the second scope that we created. So what it's in essence doing is allowing us to assign IP addresses to this computer or this computer, since they're DHCP clients, from either one of these ranges. Both of these ranges would be valid. So this machine might broadcast out and get an IP address of 192.168.1.7. And this machine might broadcast out and get an IP address of 192.168.2.7. Okay, because these scopes are now enabled essentially on this one segment because we are going to create a SuperScope. Okay, now the last thing. That's all well and good, and that may be understandable to you. No problem here. So this machine, it's just basically saying these two scopes for one physical segment. What happens, though, when this machine does get an IP address like that? Okay, 192.168. Let's go ahead and type this in here. Yeah, I'll have to write it. What if it gets an IP address of 192.168? This pen is just absolutely terrible. 2.7. Okay, and then this one up here gets an IP address of 192.168.1.7. And you know, the last number is unimportant. We're just using the same number in this case, just as an example. Okay, so messy, but you can kind of get the feel here anyway. Well, enabling a SuperScope will allow this to happen. Okay, normally it wouldn't be able to. The problem now is, though, according to TCP/IP specifications, these two systems still cannot communicate because, you know, if you look at the network ID 192.168.1, 192.168.2, they're on a different network ID. These systems cannot communicate with each other without going through a router. Okay, and a router essentially is kind of like a translator. It's going to sit there and pass information back and forth. Okay, and in our situation, what we'll do, we're just going to enable RS, okay, and turn this machine into a router. Okay, so what will have to happen is every time a DHCP client in this segment with the 192.168.1 address wants to talk to a computer with 2 dot something, we're going to have it forwarded to its default gateway up here, and then essentially what we'll see is this machine will forward that information up here, and then it'll tell us where we need to go. It's actually going to allow us to then communicate with this computer. So this machine is actually going to route traffic back and forth between these two computers. Okay. Without that router in place, this machine will not be able to talk to this one. Okay, and the same thing in reverse. When this machine wants to talk over here, we're going to have to route traffic up here. This is going to act as our default gateway, and then this machine's then going to pass that on to that machine. Okay, now this is really kind of a silly setup. Okay, and we're really doing this for testing purposes, just to give you a feel for how this would work. SuperScopes, they can be used in a production environment, but definitely there's better ways of doing things. And to set up routing on this machine, basically just to pass traffic back and forth between these two machines in the same physical segment, this is kind of a waste of resources. You're going to be taxing this DHCP server to do more work when these two machines should be capable of talking to each other directly. Okay, so neither here nor there, though. What we're going to focus on is just setting the SuperScope up just to give you a feel for what you can do, the capabilities, and what needs to be done to make it work. Okay, let's get started with this. First thing we're going to do, we're going to connect over to server 3, okay, and we're going to make this machine into a DHCP client. Okay, so we're going to have to do a couple things, erase some settings, so on and so forth. So remote desktop connection over to server 3. Okay, and we're going to start off by going into the DHCP console, and we're going to unauthorize the DHCP server first. Okay, so I'm going to right-click here, and I'm going to go down here to Unauthorize. And what this is essentially doing is taking this machine out of the list of valid servers in our Active Directory. And if you look right here, it tells us that removing authorization for the server is going to cause DHCP to not work anymore, which is what we want to do. So we click Yes. Okay, give it a second here. Okay, and this machine, even though it has a red or a green up arrow here, is actually not going to be working properly. Okay, if we try to get an IP address from it, it's just not going to work. Okay, in addition, I'm going to go ahead and delete this scope. We're not going to be using this anymore. You can deactivate it. It'll accomplish the same thing. Okay, and then we're going to even go one step further, and we're going to uninstall DHCP. I don't want any problems here whatsoever with this outstanding component. So we'll go into Control Panel and then go into Add Remove Programs. Okay, and the same thing, just kind of in reverse of what we did to set this up. We're going to go back into Add Remove Windows Components, go into Networking Services, uncheck the DHCP box, next, next, OK, finish, whatever we need to click, and it'll just take a couple seconds and DHCP will be uninstalled. Okay, so I'm going to stop this video right now, and what we'll do is we'll just wait for this to finish up, and it won't take long, and then DHCP will be uninstalled, and we'll go forward from there. I decided to start this up just momentarily here, just to make sure you know exactly what we're doing. You just need to come here to Networking Services, double-click it, and then uncheck the DHCP box. Okay, so we can click OK, next, okay, and then wait for this to uninstall. So I'm going to stop the video now, just take a couple seconds, and we'll start it back up again once DHCP is uninstalled from this computer. Okay, DHCP is uninstalled from this computer, so we're going to click Finish here, and then we're all set with the Add or Remove Programs wizard here. One more thing we do need to do on this server, however, is turn it into a DHCP client. So to do this, it's real simple. You should know this already. We're just going to go up here to My Network Places. That's not My Network Places. We don't have it here, so we're going to have to enable this real quick. For some annoying reason, they decided not to put My Network Places as a default option on a server. So anyway, okay, right-click My Network Places, go to Properties, and then right here, what we're going to do is just change the IP address from a statically configured IP address into a DHCP client. Now, what you're going to notice when we do this, we're going to be disconnected from this machine because we no longer have the same IP address, and we're also probably not going to be able to get an IP address from a DHCP server because we're going to be taking the other one down momentarily, taking a scope off. So we may not be able to connect over to server 3 for a little bit of time here. So we click OK a second time, and we will probably never see this desktop because at this point right now, we are no longer connected to server 3. And if I try clicking here, I probably can't open up anything or do anything at all on server 3 here. Okay, and you can see I'm clicking right now, but nothing's happening. So what we're going to do is just close this desktop connection, since we can't do much with it anyway. Okay, we'll give it a second here to close. Okay, so that's closed down. The next thing we're going to do is we're going to connect over to server 2. Okay, and server 2, we got a little bit of maintenance work as well on server 2. Okay, on server 2, what we're really going to do first off is just delete the scopes that currently exist on server 2. So we're having a little bit of problem getting over that. Let's see what the issue is here. Could easily be the IP address here on XP1. Messing around with DHCP can definitely affect things. So let's first try the IP address of server 2, which is 192.168.1.200. Okay, see if that works. If it doesn't, well, let's go run ipconfig. It looks like it's not going to work. Maybe we have a misconfigured IP address here. Okay, now this looks okay. I don't see any problem with this right now, so should be okay. Next guess, most likely what it is, we still have our cable unplugged from what we had done previously in lab 2. So let me stop this just for a second, plug the cable back in, and we'll try this one more time. Okay, the cable's plugged back in. And what do you know? We need that network cable plugged in before we can connect over to it. So here we're sitting at the DHCP server on server 2. This is going to be our only DHCP server that's running in this lab. We're going to delete this scope. We're going to start from scratch. So we have no leftover information that we're worrying about here. There's no server options. We can leave this authorized, however. We don't need to unauthorize this or uninstall DHCP because we'll still be using a service on server 2. What we're going to do, though, is we're going to create a couple scopes. Okay, and to do this, this is really exactly how we've set it up previously. Okay, so we're going to just right-click, go to New Scope, and now we're going to go through and create the 2 different scopes for our multiple IP addresses. And that's something that we'll have to do first. We'll set up this first scope, then we'll create a second IP address and worry about the second scope at that time. So this scope, I'm just going to call this one Scope 1, and I'm going to put in the network ID. 192.168.1.0. Click Next, and the start and the end IP address. Okay, 192.168.1.1 through 254. Subnet mask is 24 bits, 255.255.255.0. Click Next. Exclusions. Do we want to exclude anything? Well, if you want to exclude something, typically what will happen, exactly as we've done before, we're going to be excluding our main IP addresses for our servers. So I'm going to add in here, okay, server 1's IP address, server 2's IP address, the router's IP address. Okay, and that's all we'll do for right now. Okay, so click Next. Lease duration, we're just going to leave this at the default 8 days. Next, and then DHCP scope options. Now we're going to configure these later, so I'm going to put no right now, because I want to talk a little bit about these before we go in and start configuring these right now. So click Next, and then Finish. So we have one scope here. What we don't have is an active scope, so it's currently not giving out IP addresses. Okay, now, before we create our second scope, let's go take a look at our diagram here once again, just to refresh our memory of what we're doing here. And we'll leave this, I think. Okay, now, remember, we're setting up 2 scopes, and the reason we're setting up multiple scopes is because we want to service this giant number of new computers that we expect to have. Okay, so we're expecting in the neighborhood of 400 computers over here. Okay, and 400 computers, there's no way that they could be serviced by just one scope, 192.168.1.1 through 254. Okay, we're going to run out of IP addresses if these servers or machines are all on the network at one time, and they will be. So we're creating a second scope, joining these two together and creating a super scope, which will then allow us to give out IP addresses from both of these ranges. And what we're going to have to do, we've got to configure this server here with this network ID or IP address of 192.168.2.200. What this will allow me to do, once I've configured this other, what we call virtual IP address, it'll allow this computer to communicate with this system or any other system that ends up getting an IP address that looks like this. You know, it has a 2 in it instead of the 1 up here. Okay, and it's going to be able to act as a router as well. So this is an important step really in our lab situation, or if you're setting up a similar situation in your network. Typically, there's no reason to set up a virtual IP address like you see here, but we're going to go ahead and do that now just to enable server 2 to communicate as we just specified. So we're going to minimize DHCP. We're just going to go over to My Network Places, which isn't on this computer either for some reason. Okay, so My Network Places. Right-click, Properties. Okay, here's my one network card we're working with. Okay, and I'm going to go down to TCP/IP. I'm not going to change this though. I'm going to go to Advanced. And when I go to Advanced, I have a setting here for IP addresses. I'm just going to add another IP address. And I'm going to make it 192.168.2.200. So everything is the same, but we've changed the network ID by changing this from a 1 to a 2. Subnet mask 255.255.255.0, so you can see that this is indeed the network ID. Okay, so now I've added that IP address. That's all that I need to do here. Okay, and now I can go back in here to my DHCP console, and I'm going to create that second scope right now. Okay, so right-click, New Scope. We'll call this Scope 2. Okay, give it the network ID, and now we need our same starting IP address and ending IP address. Okay, looks good. Same subnet mask. Exclusions. In this case, there's not going to be much. We're going to add one exclusion. The one exclusion we add is going to be for server 2 itself. We don't want this IP address to be given out because no other servers on this network have a 192.168.2.IP address except for this virtual IP address that we just assigned to server 2. So we're going to assign 192.168.1.2.200 as the one and only exclusion. Click Next. Lease duration's good. Next. Do we want to configure these options now? Let's say no, and we'll come back here in just 1 second and do that. All right, so now we have 2 different scopes, okay? One for 192.168.1.0 and the second for 192.168.2.0. Now let's talk about some of these scope options. We're going to go back to our diagram for reference to this. We'll clean it up here a little bit. Okay, scope options. Well, basically our choice is we have 2 different scopes. Here's scope 1, here's scope 2. Here's a computer that's got an IP address from scope 1. Here's a computer that's got an IP address from scope 2. What are going to be the options that we need to specify? And remember what we do typically in DHCP. We specify DNS servers, DHCP server, or I'm sorry, Win servers. Okay, and then lastly we specify a default gateway. Okay, so let's identify this. Here's our DNS server right here, okay, and it's 192.168.1.100. This is its one and only IP address, and this is fine. Even though this IP address exists on this network, we can set this network up in a way where even computers that have two network IDs will be able to, get in touch with our DNS server over here. Same thing with WINS. So DNS and WINS, we're going to have the exact same configuration on both of our scopes. That's going to be 192.168.1.100. Our default gateway is going to be a little bit different, however. Okay, and what we're going to have to do here, it's a little bit different, a little bit trickier. Let's imagine for a second that we don't have this guy here at all. Let's just cross this out. Let's not even worry about the internet, just so we can set this up and get this working. Okay, so make it even crossed out more. Okay, let's just worry about our local segment that we have right here, and let's not even get into the default gateway side. What's our default gateway have to be in this case then? Okay, what's our default gateway have to be? Well, when this machine wants to communicate, if it can't talk to another machine on the 192.168.1 network, what machine does it have to forward all of the communication to? Since this machine is acting as the router, this is where it's going to go, just as we specified before with those arrows. Okay, and because this machine has an IP address with the 192.168.2.200 IP address that exists on the 2.network ID, it's going to be able to forward information down to this machine. Okay, now server 3, its IP address, remember, is 192.168.2.7. So if it's trying to communicate with another machine, let's say 192.168.2.10, it's going to have no problem doing that. Okay, it's on the local segment. It's got the same logical IP address, same network ID, so communication will take place and we won't even have to worry about the default gateway. If server 3, however, needs to communicate with server 1, server 2, see the IP address, or not server 2 because we have two different IP addresses, but server 1, XP1, or any other machine with a 192.168.1 dot something IP address, it's not going to be able to without forwarding it through this router. So this is what the default gateway is for the second scope. It's going to be pointing back to this machine. Okay, so scope 1 is going to point to 192.168.1.200, okay, right here, and scope 2 is going to point to 192.168.2.200. Okay, so let's go ahead and configure that now. We're going to connect back over here to server 2 and we'll set these up. So here's scope 1, open this up, go down to scope options, configure the options, okay, and we're doing it the manual way, but that's okay. We could have done this, if we knew this ahead of time, we definitely could have done this through the the wizard that we saw before. Okay, so this is for scope 1, so we have to make sure we get the IP address correct. 192.168.1.200. Okay, that's good. DNS servers. Same IP, or no, different IP address, 1.100. Okay, and then we're also messing with the Win servers. We're not really using this configuration, but since we have it specified, we'll go ahead and enter it in here. Okay, and we talked about this before. This is really for Lab 6 and WINS, but this is the most common and the default WINS NetBIOS over TCP/IP node type is 0x8, which equals H node, which stands for hybrid node. Okay, more on that, like I said, in Lab 6. Okay, so that's all that we really need to do here. So we click OK, and now we have these 4 scope options configured for us. Okay, so not a bad deal. Okay, and as we specified before, here's the default gateway. That's the same thing as router, 192.168.1.200. Okay, so that's pointing all of these machines to this IP address. Okay, and then we have DNS and WINS pointing off to our DNS and WINS servers, respectively. Now, scope 2 is going to look similar, but we're going to have a little bit of difference. Okay, and the main difference comes right here on the router. instead of trying to forward to 192.168.1.200, this is not going to work. We're going to have to forward these clients to 2.200. Okay, that's the other side network card, the one that exists on the 2 network for all these 2 network ID computers. Okay, we'll go ahead and configure the same settings for the DNS server and the Win server. That we just saw a second ago, so these aren't any different. Okay, then we click OK, and if we look at the overview here, apparently I didn't add this in, let's go ahead and fix that. Okay, if we look at the overview here, let's compare this. Okay, we have hybrid mode, no big deal. 100, 100, 2.200. Now I'm going over to the other scope, 100, 100, 1.200. Okay, and just to reiterate one more time, what we're seeing here is these machines, ones that pick up 192.168.1 IP addresses, we want to forward them to this IP address. This is an IP address that they can communicate with. Okay, let's get rid of some of this mess over here. Okay, because I want you to definitely be sure you understand what's going on here. Okay, so one more time then. These machines can forward to this IP address because we have routing enabled, or we will in a second. What happens is this machine basically takes that and then sends it right back out this side interface, and then we can go communicate from this IP address down to this machine. Okay, and this machine meaning any machine with a 192.168.2 network ID. If server 3 or another computer on this network ID wants to communicate up here with the 192.168.1 guys, well, it's just going to forward off to its default gateway. Okay, I'm just pointing to the same IP address, 192.168.2.200. That goes through 1.200, and then we forward over here to these guys. Okay, and that's how TCP/IP works. So you may or may not understand that right now, but that's essentially what we're doing right here. Is just setting up a router and enabling routing. Okay, so what we're going to do then, come back over here. This should be set up correctly. You shouldn't have any other issues with this right now. The only thing that we really need to do is activate our scope. So we'll go ahead and do that. Right-click, activate, right-click, activate. Okay, and then we need to do 2 other things. And the first thing we'll do, let's go ahead and set up a SuperScope. And I probably should have, before I activated these, I should have set up the SuperScope. So let's do this, new SuperScope. Okay, and we'll name this WBC Master SuperScope. Lack of a better name. Here's our available scopes. Okay, Scope 1 and Scope 2. Finish. Okay, and just like that, now you see that it creates the SuperScope heading up here, and underneath it we have those same scopes that we had before. Okay, so these are what's considered a SuperScope. Okay, so this one DHCP server now is going to give out IP addresses on either one of these segments to just local machines broadcasting for an IP address. Now, let's enable routing. This is just really going to be a wizard that we're going through here, but we're going to go to All Programs, Administrative Tools, Routing and Remote Access. Okay, and we just need to right-click on the server and go to Configure and Enable Routing and Remote Access. Now, we're going to specify one of the default options here. We're just going to be setting up a, let's see here, not this. Remote Access, Dial-Up VPN, nope. Not NAT. We're not setting up a VPN. Secure connection between 2 private networks. Connect this network to a remote network such as a branch office. This is a special kind of VPN. Custom configuration. Let's try this out. Okay, what are we going to do? Oh, select the services you want to enable on this server. VPN, nope. Dial-up, nope. Demand dial, nope. NAT, nope. LAN routing. Okay, this is all that we need to do is just specify local area network routing, and this is going to just set up a basic router. It'll just take a second here, and this should start up successfully. Okay, and then we'll do a couple tests just to make sure that routing is actually working correctly. Okay, so here we have now routing enabled, and if we look inside here, it should show us both our interfaces. We have come on. Well, it's not showing us right now, so let's come back in here. Here's where we can look at it though. If we look here and go to properties, we see we have our IP address 1.200. If we go to advanced, it will show us that we have the second IP address as well, 2.200, but not so important. What I want to do is test this out, make sure that routing is actually set up correctly. If I come back here over to the XP machine, what I should be able to do, first off, to give you an idea of what we have here right now, 192.168.1.128, so we're on the one network ID with this machine. Well, I should be able to ping the DHCP server, which is 192.168.1.200. Okay, and if I hit that, yeah, we can ping the DHCP server. Well, normally, if routing wasn't enabled, I would not be able to ping 192.168.2.200. Okay, and the reason, well, it's just not on the same network ID, and unless this network were available to us, we wouldn't be able to reach it. Let's see if we can do it at this time right now. Okay, presently we can't. Okay, and I can tell you why. Our default gateway up here, we ran ipconfig, is still pointing out to the internet. Okay, and for our purposes, we're going to change this right now. And what we'll do, let's go ahead and see if our DHCP server is giving out IP addresses. So I'm going to release that old IP address DHCP configuration I had, and we're going to renew it. Okay, and we'll take a look and see what IP address we actually end up getting. Okay, now we ended up getting 192.168.1.128 again, and that's, we talked about this in the last video. This is just par for the course for a DHCP client. It tends to accept and take the exact same IP address that it had previously. Even though it's going through a totally new DHCP server, okay, you can see that it holds on to that same IP address. Notice, however, the default gateway has changed. Now it's 192.168.1.200 instead of .254. So if I attempt to ping that same address I did before, 192.168.2.200, now I am able to actually reach it. Okay, so what's happening, looking at this diagram, what's happening here is I'm pinging this IP address, okay, but when I ping, I can't ping this IP address directly. I'm sending this off to my default gateway. Okay, my default gateway then goes, oh, I know where that IP address is. It's right here. Okay, because it's actually an IP address on this server. Now, what you're going to see here in a second, when we get this server 3 configured with a .2 IP address, we should be able to communicate that way as well by going through the router, through server 3, and then back again. Okay, well, let's take a look at something. And what I'm going to have to do first, I'm going to have to connect over to server 3. And to do this, I'm going to stop the video. And the reason I'm going to have to stop it, well, remember before we ended that lease kind of in the middle, we weren't able to renew the lease on server 3, and now that DHCP is up and running, I'm going to have to go over to the actual console of server 3, get that up and running, and then once I do that, we'll take a look at the IP address information that it picks up. So I'm just going to stop this momentarily, fix that, and we'll be right back over with it. Okay, I just simply went over to the server 3 console, I ran ipconfig renew, and then what that did was it just gave us an IP address back again, and what we'll do now is we'll just form a remote desktop connection over here to server 3, and server 3 picked up the IP address 192.168.1.130. Okay, and we can even use server 3's name. Okay, so it's connected, and we're going to go ahead and run ipconfig over here and take a look at what information was picked up. Let's make sure that it did indeed pick up the right information. So ipconfig /all. Okay, and you can see 192.168.1.230, gateways pointing to 200, DHCP servers pointing to 200, and we have our DNS and Win servers pointing to 100 like we configured. Okay, so it's working. And the lease you can see right here, November 9th, 107, 40 seconds. That was just 2.5, 3 minutes ago. Okay, so if we ping right now, we should be able to ping over to 192.168.2.200. Okay, and you can see that we can. What's this indicating to us? Well, right now, server 3 still has an IP address over here. It's just able to ping, go through this IP address, and reach this network card. We still haven't gone through our full throttle test of making sure that one machine can talk to another machine that has a totally different IP address on our network. Okay, and let's talk about why that is. Now, keep in mind how many different IP addresses we set up. We set up quite a few in the scope. Okay, so let's go take a look at server, where are we going here? 200, and we'll open up this DHCP console. Now when we look here, here's scope 1, here's scope 2. If we take a look at the address leases, we see that two machines actually have leases, okay? XP1 and server 3, just as we were talking about a second ago. Now, how do we make sure that, to test this out, we start getting some addresses down here, because currently nobody has a lease? Well, unfortunately, for our case, and in this circumstance, the way it ends up happening is we end up filling up all of these different leases first. And keep in mind our pool size. We've got 1 through 254 with only 3 different IP addresses excluded. So we have, essentially about 250 IP addresses to give out first before we start even dipping into, the second scope here. Well, we're going to force this process along. Okay, and to do that, what we're going to do, well, we're going to create some artificial exclusions. Okay, some artificial exclusions. And what I mean by that, well, let's just create some exclusions so we're kind of forcing these machines to have to take an IP address from the second scope. So I'm going to exclude 192.168.1.252 all the way through, oops, I didn't want to do that, 1 all the way through 252, okay? And this is just a lab scenario. You would never want to do this. I mean, keep in mind what we're doing. We're excluding all of these IP addresses, so the DHCP server won't be able to give out these IP addresses. What this is in effect going to do for us, though, is exclude all of these IP addresses, leaving only 253 and 254. Okay, 254 is also excluded, so it's really just going to leave us 253. Okay, so I click Add here. Okay, and we get this error message. So what I'm going to do, let's just get rid of this exclusion. This will make our job a little bit easier. Okay, and the only reason I'm getting rid of it is because it's going to be included in our all-encompassing exclusion range. Okay. Now, if you look at this range, we've excluded 1.1 through 252 and also 254. It just leaves us one IP address out of this range, 253. So the next time one of these machines does a release and renew, it's only going to have one IP address from this scope to pick from. Okay. Now, in the second scope, if we wanted to really force the issue as well, we could do that exact same thing. Okay, we could just set it up so there's only a couple IP addresses left. I don't think it's going to make a difference, though, so we're going to leave the second scope as is. Okay, and what's going to happen, what I'm expecting to happen, we will do an ipconfig/release, ipconfig/renew, and XP1, we'll do that on server 3 actually, we'll pull down an IP address, okay, but when we try doing it on the second machine, it's not going to pull down an IP address from the scope. It's only going to be able to pull it down from scope 2. So let's go ahead and minimize this and try this out. So we're sitting on, right now, the XP1 machine. So I'm going to run ipconfig release, give this IP address back, and then ipconfig renew. Okay, and then when it renews, we should pull an IP address from scope 1. Let's see what happens. Okay, see, here's the one IP address that was left over, 192.168.1.253. All the other information should be okay, should be exactly the same. Okay, so we pulled this IP address. Now what we need to do, if we connect back over to server 3, we're going to do this exact same thing. What's going to happen, unfortunately, though, when we do this release, we're going to be disconnected. Okay, so you'll see that here in a second. Okay, so it will release it, but as you see here, as soon as this registers with it, all of a sudden now we don't have any control over this computer, and that's because the remote desktop connection has basically been interrupted because it doesn't have an IP address to connect to anymore. Okay, so we're going to close this down. Okay, and then what I'm going to do is just stop the video here momentarily. I'm doing the exact same thing I did before. I'm going to stop the video, go to the keyboard monitor, sit right in front of server 3, run ipconfig renew. Okay, that's the only way we can get that to actually work from here. Okay, so we'll be right back. Okay, I finished up over on server 3 and just basically ran ipconfig/renew. It did pick up an IP address. I ran ipconfig before I left there to make sure. And it's 192.168.2.1. Okay, 192.168.2.1. And we can test that right here from the client machine. 2.1, and you can see we can actually communicate with it right now. Okay, so before we connect over to it as well, let's go back to our DHCP server. Here's scope 2, here's scope 1. We're going to go over here. Remember, our address pool, we've blocked off everything but 253. So when we look at our address leases, we see that we have, what are these leases? Some old leases here basically. So let's refresh this. Okay. We only have 192.168.1.253 is the only lease out there. That's to XP1. Now, down here on scope 2, if we take a look at address leases here, we don't see anything. Let's refresh this here again. What do you know? We've got 192.168.2.1, okay, and this is server 3. So you can see that this machine actually gave out an IP address over here to machines that are on the same physical segment, and normally this would not happen. Okay, it would not give it an IP address. The reason we're able to communicate with it now, remember we just were able to ping 192.168.2.1 from this IP address, 1.253, is because we have routing set up over on that server as well. Okay, so keep in mind what we have now. Essentially, we've got XP1 is on subnet 1, and server 3 is on that second subnet from the second scope. 192.168.2.1 is the IP address it actually picked up. Okay, and essentially, we've got our default gateway set up correctly, so when we ping from here down to here, we can't ping and talk directly like this. That's not going to happen. Okay, we have to ping and go through the default gateway, 192.168.1.200, have it routed through the router, and then sent back out through 2.200, and then we're able to communicate with server 3 that way. Okay, let's just see if we can form a remote desktop connection over there. We'll check that out and we'll confirm all this ourselves. Okay, so we're just going to open up a remote desktop connection. Now, we could try going out to server 3. One thing that's going to happen, however, we don't have a Win server set up. So when we try this, we may not get out to server 3 using this NetBIOS name. And you can see right now it's taking quite a long time to open this up. It doesn't look like it's going to work. Okay, so instead of using server 3, we're going to specify the IP address 192.168.2.1. When I connect over now, assuming we have the right password in, we're able to log right on. We're actually accessing server 3 that's on a different logical subnet, 192.168.2.1. And we can confirm that. We just go down here to IP config/all, and we can take a look at the IP settings here. 192.168.2.1, our DHCP server. Look at this. We actually picked it up off of a different subnet, 1.200. Okay, this is a critical setting right here, though. And I've talked about this several times, but if you don't have this default gateway setting configured correctly, 192.168.2.200, this whole thing's not going to work. You're not going to be able to communicate back and forth between your client machines. Okay, between clients and servers, so on and so forth. Okay, so it doesn't really matter what this is, but the IP address and a default gateway, these network IDs always have to match up anytime you're setting this up. Not just in this example, but in a real world example as well. Your IP address and your default gateway, these network IDs always must match. Okay, so we got everything set up and working appropriately here. Okay, basically then in sum, for the most part, a SuperScope is not going to be part of a normal environment, but they can definitely, it's real easy, real quick to set up. It can definitely be helpful if you need to add extra IP addresses when you're in a crunch. Okay, that wraps up Lab 3. We'll see you back here real soon when we go into Lab 4, and we talk about a DHCP relay agent and how we can set that up in Server 2003.